And day 21, unit 6. This is expressions. Okay, so again, fill this sheet after you've done the questions. See how you are. Okay, so here we go. Write each power. The 10th power of 8. The 8th power of 10. Write each power. The 10th power of 8. Nobody who talks like this. The 10th power of 8. 8 to the 10th. Okay, you know what? Here I'm gonna admit that I'm not too sure. 10th power of 8 would be 8 to the 10th. The 8th power of the 10 would be 10th to the 8. I'm thinking that's it. Okay, so I wouldn't be too concerned with this, but I am pretty sure the 10th power of 8 would be 8 to the first power, 8 to the second power. Okay, I think that's right. 8 to the 10th, and then the second one 10 to the 8th. Let me know if you find out that's wrong. Use exponents to write each expression. Okay, 5 to the third. Okay, please stop thinking that 5 to the third is 15. It's not. It's 5 times 5 times 5. Okay, which is going to be 125. Okay, 10 times 10 times 10 times 10 times 10 to the fifth. Half would be, and write it with exponents, and that would be to the third power. 1/2 times 1/2 times 1/2. It's going to be 1 times 1 times 1, which is 1, and then 2 times 2 times 2, which is 8. So it's going to equal to 1/8. Okay. Find the value of each power. What's going on? Okay, here we go. 8 to the third, 9 to the 10th. Okay, all right, so here we go. 8 to the third is 8 times 8 times 8. 8 times 8 is 64. And 64, I'm going to multiply by that last 8 over there. And let's say 2, carry a 3, 48, 512. 9/10 to the first power, so write it like this. To the first power, it's just simply 9/10. Okay. 4. Write the missing exponent. 8th. What is 8th? 8 is equal to 2 to the third power, because it's 2 times 2 times 2, which is 8. And this would be, again, I'd rather you put parentheses over here like this, and that would be to the second power, because 8 times 8 is 64, and 9 times 9 is 81. Write the missing base. What number to the third power multiplied by itself 3 times equals 1,000? I'm going to say that's 10. 10 times 10 is 100, and 100 times 10 is 1,000. 729, 7 times 7 is 49, times 7, no. 8 times 8, 9. I'm going to say 9. That's something right. 9 to the third power. 9 times 9 is 81, and 81 times 9, it's 729. 729, yep, so it's 9 to the third power. Okay. Eric was in charge of making sure his classmates, blah, blah. Eric emailed 5 classmates. Each of those classmates but here's a person, Eric. He emailed 5 people. 1, 2, 3, 4, 5. And each of those 5 people emailed 5 people. 3, 5. This person, 1, 2, 3, 4, 5. This guy emailed 5 other people. 5, and this guy emailed 5 other people. 5, and this guy emailed 5 other people. 5. Okay. And then these guys here that we emailed another 5 people. So that guy emailed 1, 2, 3, 4, 5, and that guy 5 other people, 5 other people. So there's a lot of people. So the third round, this is the first round, 1 person. The second round was 5 people. In the third round, how many people actually received those emails? So 5 to the first was the first round. 5 to this, wait a second. Sorry. 5 to the 0 was the first round. 5 to this first power was no. yeah, 5 to the 0, 5 to the first was 5, and then the second round would be 5 to the second power, which is 25 people. Okay, what would be the third round? So this would be the first round. Second round would be 5 to the first power. The third round would be 5 to the second power, which is 25 people. 5. Right, so ignore that. That's what my confusion is. So the third round would be this group of people. 1, 2, 3, 4, 5, which is 25. Okay, so in the third round, 25 people got to email. Okay. N divided by 8, that's easy. I'd rather you write it like this, but if you wrote it like this, it's still okay. P times 4, you can write it like that, but I'd rather you write it 4p. The coefficient should come first. 13 added to x, that's just this. 4, it's 16 minus y. It's not a turnaround word, so it's just 16 minus y. Write a phrase, so m plus 8, just keep it simple. N increased by 8. Okay, m added to 8, all those work. Okay. 11x, you can say 11 times x. The product of 11 and x. Okay, so you got options there. Lane's total points scored during last night's game was 12 points, greater than his first game. That P represents the total for his first game. So this is how much he scored his first game. And then the second game was whatever he scored in the first game plus 12. Okay, so how much did he score in the second game? Well, whatever he scored in his first game, let's just pretend he scored 5 points in his first game. So in his second game, he would have scored 17, 5 plus 12. So it's whatever he scored in the first game plus 12. And we don't know what he scored in the first game, so we represent it by P. Okay. All right, so this would be the expression. Okay. 95 plants for sale. P plants were sold. Write in the algebraic expression how many plants are left. Okay, so this is how much you started with. This is how much you sold. And to find out how much left over, this would be the expression we would use. Write an expression for a product of two variables. Well, the product is multiplication. We're multiplying to something. Let's just call A times B. There you go, two variables. Write an expression for x less than y. X less than y, if you just translate it as it is, x is just x, less than is just subtraction, and y is y. Because a turnaround word, it becomes y minus x. Evaluate each expression. Okay, so the expression is 3x. Okay, 3 times x, and we know that x equals 6, so let's substitute, so it becomes 3 times 6, and the answer is 18. 3m, 3 times m, and m we're going to substitute with 1 6, so it becomes 3 times 1 6. So how do we multiply a whole number with a fraction? We can change this whole number to a fraction, making it by over 1. And multiply, numerator times numerator is 3. 1 times 6 is 6. 3 6, we can leave it as 3 6. If they ask you to simplify, you can obviously write a half. Okay. Write an equivalent expression for the expression that's given. So this one, hopefully you still remember, distributive property, but we're going backwards here. Okay, so this one we want to make it look like this. Okay. So you can use the ladder method. No, do the ladder method over here. 4 and 4n. All right, what number goes into both 4 and 4n? Well, 4 goes to 4 one time. 4 goes to 4 1n, 1, and we'll write the n together. Can we go again? No, we can't. So the GCF, or the greatest common factor, the biggest number that they have in common is 4. And we write 1 over here and 1n. And we can always double check using the distributive property. 4 times 1 is 4, check. 4 times 1n is 4n, check. Okay, so that would be one possible solution. Okay. Here, we're actually doing the distributed property. 5 times b is 5b. Then minus, and then 5 times 1 is 5. So there is another expression. These two expressions are identical. Name the property used. This one is the commutative property of multiplication. Okay, right? Changing the order in which two numbers are multiplied doesn't affect the product. Number 4 looks like, yeah, it is. This times this, and then this times that. So that is the distributive property. And el número 5, it's, let's see, this is the associative property of multiplication. Associative property. And this is, again, the commutative property of multiplication. Okay. All right. Circle expression that contains like. Circle the expressions that contains like. What? Circle the expression that contains like terms. What does that mean? Circle the expression that contains the like terms. Well, all right. So the like terms. Oh, I see. All right. So does this have like terms? So does this have like terms? Let me circle it. Does this expression have any like terms? No. X, Y, no, they're not like. And X, Y is not. It's definitely different than Y and X. So this doesn't have any like terms. This one does. So this is the one that we want, and I'm going to erase this. That expression does not have any like terms. This has like terms. This and this are like terms. Okay, we can remember when we did the burgers and the French fries and all that stuff. So the X and the X are the same because they're both to the second power. Okay, X to the 5th plus X to the second power plus X. This does not, although they're all X's, they don't share the same power. So this is not. They're not like terms. And this one, it is. Okay, they're both Y's, and they're both Y to the 4th power, which makes them alike. And we can actually add these two, giving us 3, no, sorry, not 3, but 4y to the 4th. Okay, remember there's a 1 here, so if you were to add these two terms, you would get 4y4. Okay. Combine like terms, and here we go. Can we combine 8x4 minus 3x4? Yes. So we'll subtract the coefficients, and that gives us 5x4. Here I can add these two, 3x and 4x. That gives me 7x. And the 5 I'm not going to add, just going to leave it alone. And they're all u, so 2u plus 5u, 7u. Minus 1u, there's a 1 here. Okay, it's going to give us 6u. Create a value the expression 6b and for b equals to found both expressions equal 32. Is 16b? Okay, so I think this is what you mean. Here's two expressions. One is 16b, and the other one is b to the 5th power. Okay. Are they equivalent expressions? No, they're not. They're both b's, but one is b to the 1st power, and one is b to the 5th power. So they're not equivalent expressions. Can they equal the same thing? Maybe. Let's find out. So b equals 2. So instead of b, I'm going to write 2. Sorry, shoot. So it's 16 times 2, and 16 times 2 is 32. So the value of this expression when b is 2 is 32. Over here, instead of b, I'm going to write 2 and 2 to the 5th power. And it's 2 to the 5th power is 2 times 2 times 2 times 2 times 2, which is 2, 4, 8, 16, 32. So both expressions equal 32. Okay, yes, they are. But are they equivalent? Sorry, forget everything I just said. Forget. Yes, they are. Yes, they are equivalent expressions. No, they're not equivalent expressions. They're equivalent expressions when b equals 2. Okay, when b equals 2, they are equivalent expressions. Okay. Now, let's say b was something else. So let me try here. 16b and b to the fifth power. Let's change the b to 5. When b equals 5, what happens to this expression? So this would be 16 times 5, which is 80. And this would be 5 to the fifth power. 5 to the fifth power. Jeez, I don't even know what that is. Let me just type 5 times 5 times 5 times 5 times 5. 5 to the, it's equal to 5 times 5, 2, 3, 4, 5, equals to 3,125. No. So the question is 16b and b to the fifth power equivalent expressions? No, they're not, except when b equals 2. When b equals 2, they gave you the same answer. But when b equals 5, and I just proved it over here, they give you the same answer? No. One gave you 80, one gave you 3,125. Okay, so they're equal when for b equals 2. Okay, that's it. All right, so I don't know if b equals 4, will they be the same? I have no idea. When b equals 10, will they be the same? Definitely not. Okay, so, but we know that when b equals 2, they are equivalent. All right, so they're not equivalent expressions for other values of b. Okay, and I think that's that. Yeah, no, yeah, that's it. That's that.